So lots of different people claim Charles Darwin. Historians, philosophers, sociologists, even psychologists. So I'm a biologist. I study biological molecules, so that irritates me a little bit. But I get it. It makes sense to me. I think I understand why there's this broad appeal across all these different disciplines, and that's because Darwin's work, his most influential intellectual work, placed humans in the natural world, placed humans in the universe, not at the center of the universe, certainly, not transcending the universe, but part of the natural world, and subject to all of its natural laws. And that's a real revolution in how we think about ourselves as human beings. So, of course, there's going to be a lot of interest across all of these other fields. But another thing that irritates me a little bit, and this is, Mariam actually got this really well in her talk, which was great, by the way, that humans think that they're special. There's this ingrained part, there's this ingrained element in society and culture that we're somehow special within the universe, or that we're special even in the biosphere, even though there's no objective way to make that claim. And I would say that the only thing that makes us special, or might make us special, is our capacity to recognize that we're not. And I think that Darwin understood that, because it's not a sad thing, it's not a distressing thing. It's actually a kind of enabling thing. It's quite beautiful because it frees us from all of these hang-ups that we have as humans, because we are egocentric and we are narcissists and we're full of ourselves, but if we get over that, we can really start to contemplate our place in the cosmos, which is a wonderful thing. But I won't claim Darwin for biology, because that's been done a million times over. Instead, I'm going to claim him as a really great example of how to deal with our place in the universe. So how to do that contemplating, how to think about it, and how to see how much beauty there really is there. So let's start with some first principles, as scientists like to do. So as human beings, we're surrounded by the universe. And I mean the universe in its broadest possible sense, across space and time, from this measly arm of our Milky Way galaxy all the way to the cosmic microwave background of the edge of the universe, and also within the biosphere. So life has been around for billions of years, and we're just a tiny, tiny little speck of that. So all of this universe that is around us is a kind of weight on us. And it's not a burden. It's a weight that's a function of our awareness. We know it's there. I would say that it's a weight created by our consciousness. And it's completely and utterly dark. Like, we don't know anything. Like, it's crazy how much we don't know. And for every little bit that we think we start to understand and think we know, we find the cosmic microwave background. It has all these signatures, but why did inflation happen? You know, we know all this stuff about the biosphere. We now know that life on Earth throughout time and in every ecological niche is dominated by single-celled organisms, not multicellular organisms. And evolution is defined by them and run by them. But there are so many, there's so much diversity. We know that they're out there, but we have no idea how all of them function and all the niches that they occupy. So it's just this sphere of not knowing gets bigger and bigger, and the surface area gets bigger and bigger. And the first step to becoming a scientist, I think, is an admission of ignorance. It's to say that we don't know all this stuff, and a kind of humility that goes with it. So this awareness and this understanding can bring out a lot of emotions in human beings. One of the first, often, is a kind of fear, right? I mean, we're a cozy social kind of species, and up against this infinity, it can seem a little bit lonely. The good thing is, the second emotion, often, is awe, which is something Mariam talked about. So there's a lot out there, and we don't know what it is, but it's all really awesome and cool, and we're in awe of it. And that drives, I think, the third emotion, in scientists at least, and that's curiosity. So we're enveloped by this dark unknowing, and the universe pushes up against us. It's this weight. But we push back. And that interface, where we push back, that's the scientific endeavor. And even if it's scary and maybe lonely, and there's all this awe and curiosity and all this emotion, that's where I want to be, at that interface. It's a fundamental human instinct, I would say. And it represents the scientific endeavor and the scientific state of mind. Now, I've argued, to much disagreement, that I actually don't think Darwin was a scientist in the modern sense of the word. He certainly wasn't a biologist, because biology didn't exist as a science until he came along. It was just people naming things and categorizing things. And also, the biological experiment in its modern form definitely didn't exist. But Darwin did have two character traits that are absolutely essential to this scientific state of mind. He was an amazing observer, and he was a really good conceptualizer. He was good at taking those observations and making connections and seeing patterns within the patterns. And when I say observer, I mean it generally. So I mean that observation is a kind of organized curiosity. So curiosity is this kind of immediate instinct, but if you want to actually start to understand and start to think about how to understand things, you have to organize it. And that's what a good observer does. It takes a lot of patience, it takes a lot of dedication, it takes a lot of focus. So let me tell you a little bit about Darwin as an observer, because some of this stuff is crazy. His biography, it's really amazing. He was an amazing scientist in that sense. He's in his early 20s, and he's very well placed. He's from a well-to-do family, and he's really lucky, and he gets to go on a trip around the world. Now, his description on this voyage was actually companion to the captain. The captain needed someone to talk to. And for the he's often described as the naturalist of the ship, but that's actually not why he was taken on the trip. So for the most part, during this 5-year voyage around the world, which is just an amazing opportunity at any time, let alone then, for the most part, he seems to have his own mind for company. And he's really in his element in that setup. When he gets back to England, he writes a long series of papers about all his observations, and those all his scientific observations. He was primarily a geologist, actually, rather than a natural historian. So he has all these observations about fossils, and he has all these observations about how the various mountain ranges form, and all this amazing stuff. He also wrote a more popular version of his trip. It's called The Voyage of the Beagle. It's very engaging. I highly recommend it. It's really fun reading. In addition to all this other geologizing, he has all these observations about local culture. He talks about the food that he eats on the Argentinian plains and all the different villages and how the towns are laid out. This is a person with endless curiosity and endless capacity to be aware of his surroundings. Of course, this voyage laid the seeds for his work on evolutionary biology, but there was many decades in between the Voyage of the Beagle and him writing The Origin of Species. And in between that time, there was like a 7 or 8 year spell where he completely devoted himself to barnacles, just studying barnacles. And the sexual cycle of barnacles, he wrote like 6 books about it, and barnacle fossils and barnacle life cycles and all of this stuff. And he realized, or he understood clearly from this kind of dedication, that if you really want to start to see patterns in nature, you have to realize how incredibly complicated it is. You have to pick a model system, and you have to devote yourself to it. And you have to be willing to invest the time and the effort to really wrap your mind around it. His work on barnacles is still considered definitive today, right? So this is the work of a dedicated mind. And just as a final sort of illustration of what a good observer does, his last book, in keeping with the theme, was on earthworms. He studied earthworms in his backyard, and one of the things that he did is he went out there and he wanted to see if vibrations would affect how they behave. So he sat out in his yard and he played a bassoon to the earthworms, and he reports on the results in his final book. So this is the kind of observer that Darwin was. what kind of a conceptualizer was he? Remember, that's the second thing that I wanted to emphasize about him. In The Origin of Species, he makes a lot of amazing insights. He has a lot of really great insights and a lot of wonderful biological concepts. My personal favorite is his realization that all life, or the implication of his theory, that all life is related through space and time on Earth. And this is just an amazing concept to me. It's something that amazes me every time I think about it, and I think about the way that he presents it. He presents this idea that varieties within a species are kind of like species within larger groups. There are variations, they're all sort of related, they've been grouped together, and maybe the reason that they've been grouped together as varieties is because they're all related. So all the different varieties of dog, for example, they're all kind of similar, they're related, they're grouped together. Maybe that's because they have a common ancestor. And his entire book, The Origin of Species, is about hashing this out, figuring out why this is, and presenting a monumental amount of evidence based on all his observations that this is the case. And he takes it to the next level. He says, all right, now we can look at species in nature. They're kind of grouped together. They belong to this genus. They have a common ancestor. That's why they're grouped together. And if you take two genuses, now you have these bigger groups, they have an even more distant common ancestor. And he takes this concept to its conclusion, its rational conclusion, which is that perhaps all life on Earth is related. This is a concept and a hypothesis all in one, and it makes a lot of predictions. All of modern biology, all of the stuff that I do in the lab and all of the stuff that modern molecular biologists do is about this. It's borne out in biochemistry and genetics, in all of molecular biology. He didn't have any of that. That's the evidence we marshal to show that all life on Earth probably has a common ancestor, or a set of common ancestors. All of modern molecular biology, he didn't have it. He had his observations, and he figured it out, and he got it right. And that's really just an amazing thing, that he took this state of natural history that it was at the time, and he was able to observe and to come up with these concepts that then make all these predictions and lay the foundation for all of molecular biology. So, just to wrap up, the reason I got to speak tonight, the reason I got to speak to the Empiricist League is because a couple of years ago, 5 or 6 years ago, I had the crazy idea of translating The Origin of Species into modern English. There are a lot of technical reasons for this. The book is a very, very challenging read. There are linguistic issues. Darwin had to rush. He wasn't the best writer. He had all these other pressures to deal with. It's Victorian high writing. A lot of the concepts are sort of buried. And so I did it. I spent like 5 years on it, and I did it. And it made me think about the relationship between language and science, and that's what I've been thinking a lot about recently. So I just want to end on a sort of linguistic note, and I want to say that these ideas about the universe and how we engage with it and how to deal with it and how to place ourselves as humans with it come together in language. They come together in lots of different things, but they come together in language because that's how we engage, right? We're doing it right now. Language is very, very important. And the word science to me has always had two meanings that are very different but nonetheless related in very complicated, interesting ways. And one meaning is the definition of the universe that I gave you. So science is all the stuff that's out there in the physical world, regardless of whether or not we know it or we're even around. And the other definition is the way that we actually engage with the universe, the process of science, the scientific way of thinking. And in this one word, both of those concepts come together. So that's it. Thank you.